Alright, good day guys. Talking about floor and ceiling function, it is very simple, but you need to understand something is that you can see it says the floor function of x denoted this is like more of a larger number, but the larger number we are talking about is not greater than that particular value of that variable, which is x. Now, the value you are being given to find the floor and the ceiling is the s function, and the integers. I will explain this integer when I come back to you. And this is you are being given a real number, right? Whereby the operation you are being asked to make, which is the floor function, is a unique integer of the n, which are the numbers, and it says that such that the n is less than or equals to the value you are being given, or it is less than n plus 1. Now, why it is being written that it is less than or equals to x is a process whereby, alright, I will explain that in the next slide. A process whereby you are being given a normal real value, not mainly a decimal value. In that process, your n can be equal to your x. Yes, that is true. And moving on to ceiling function. A ceiling function of x, which is noted by this, is also a real number x, where this is a unique integer of the n, such that n minus 1 is less than x, and also less than or equals to what? N. Now, if you look at this x being less than or equals to n also, it's also obeys a particular value law here, which means that something is common between these two. Now, before I talk about that, let me try to explain what we all know what we call number line. Now, let me use number line to explain something. Now, let's say you have a normal straight line. You have your 0 point here. Let's say you have 1 and you have 2. Let's say you have minus 1 and you have minus 2. So let's pick a particular value of x. So x right from the middle here, let's say we have 1.3 here, and x right from the middle here, let's say we have let's say that's a negative 1.5 here. Now, if you have to look at this now, guys, when you want to obey the floor function rule, the floor function tells us that the larger number, a larger integer, and what are integers? A number like this. Let me use z to denote integers, and these are our integers. This s is the real number, which can be either a normal decimal value. I will explain normal real numbers where I don't have decimal value. Now, since you have 0 at the middle here, it says that the largest integer, listen, not greater than this x. So far, this floor function of 1.3 cannot be greater than this x, which is 1.3. That is, your floor function of 1.3 here will be equals to 1. Here, floor. Now, if it is to be the 1.3 of the ceiling function, sorry, not really that, don't like drawing like that. So the 1.3 of the ceiling function, then looking at the law, it says smaller integer, right? Don't let this confuse you. Mainly this thing is referring to this idiot here. Now, it says the smaller integer not less than x, not less than x. That is, so far we all know that 1.3 is not actually greater than 2. So therefore, the ceiling function of x is actually what? Of 1.3, which is x, is 2. Why is that? 2 can never be less than 1.3, and also 1 can never be greater than 1.3. Are you with me? So moving on to this now, we all know that minus 1, minus 2. Minus 1 is greater than minus 2 in terms of negative value. So therefore, if you are to find the floor function of minus 1.5, the floor function of minus 1.5, it tells us that I told you guys already that larger value not greater than x. Now, at the middle of here, this point here, we all know that this value here can never be greater than x. Why is that? So far, it can never be greater than minus 1. It can never be greater than minus 1.5. So therefore, the floor function of minus 1.5 will be equals to what? A value, one more time, which is not greater than x. So that will be minus your minus 2. That is, minus 2 is not greater than minus 1.5, which we all know. Now, the ceiling function of minus 1.5 now, automatically we all know the answer already, is that what? A value, which is what? A smaller value, which is actually less than this function here. And when looking at it, we all know that what? Minus 1, this function is less than what? Minus 1. Why is that? Smaller integer not less than x. Since minus 1 is not less than x, minus 1 is greater than x automatically. So minus 1.5 for the ceiling function would be equals to minus 1. Now that is one thing. We have talked about decimal value. Now what about we having a real number? If you are being given a real number, like let's say let's say x is equals to, if x is equals to, a process whereby x is equals to the scaling function of the floor function of x and also equals to the scaling function of x is a process whereby x is a subset of let's say x is an element of a particular integer which are the same thing, let me say real numbers. Are you with me? So therefore, if I'm to compute the floor function of 1 here as a normal value, it will be equals to the same thing as the floor function of x and also equals to the what? The scaling function of what? Of x. That is what it's trying to explain to us there. And that is one thing, don't worry, when I try to fill this table up, you understand better. Alright, so we have the fractional part, and the fractional part is your normal value of x minus the floor function of x. So from here, we all know that the floor function of 3.4 here will automatically be 3, right? Are we correct? Let's confirm. Floor function of 1 from 3 is actually what? 1. Simply because it has to be less than 3.4. And this one has to be less than 3.4, that's 4. So our fractional part is 3.4 minus 3, that's 0.4. This one has to be what? Less than this. So you'll be having what? Minus 5. And since minus 5 is greater, we all know that what? Minus 5 is greater than this. That is wrong. Minus 5 cannot be greater than what? Than this. Coming back to here again, you have what? Minus 1.5. You have is equals to minus 2, right? And whereas minus 2 is less than what? Minus 1.5, that is for floor function. So therefore, this has to be less than this. So therefore, you'll be having minus 5. So you're having minus 5, guys, because this is greater than this. Then this should be less than this, should be having minus 4. So this minus this, that will be minus 4.2 plus 5, and that should give us, that's minus 4.2 minus into bracket minus 5, and that will be giving us 4.2, that should give us 0.8. Then moving to 2, I explained that real values. So this will be automatically 2, then this will be 0. This for 0, you'll be having 0, 0, 0, and this for 1, you'll be having 1, 1, 0. They are real numbers. Then minus 3, now you'll be having minus 4. Are you with me? Then for this, you'll be having okay, minus 3. You should have minus. You have minus 3, minus 3, and minus 3 minus 3. That should give us 0. So moving on to this. For pi is 3.142. So automatically, if you are rounding 3.142 for the floor function, you'll be having 3. Then for this, you'll be having 4. The negative pi is also minus 3.142. So here you'll be having minus 4, and there you'll be having minus 3. So you guys can put down this 1.1. 1.1 will be giving us 1. This will give us 2, and this will give us minus 2. This will give us minus 1. Then you put your fractional part there. So I hope I have explained some little things that you guys need to know under scaling and floor function. We'll meet another day.